This is it. The last trig function to graph. Cotangent, baby. All right. Nice thing about this is we don't have to graph tangent first. It's very similar to a tangent graph. Here we go. So, same steps. Most of them are the same steps as the tangent. First thing you're going to want to do is figure out the period, which is pi over b. In this case, b is 1, so our period would be pi. We're going to want to figure out our labels, and just like tangent, we're going to want to do half of a full period by our labels. So our steps, we're going to take a period, pi, and we're going to divide it by 2, just as we did with tangent. So we're marking every half pi. Pi over 2, pi, 3 pi over 2, 2 pi. Just like a unit circle. And if we went backwards, alright, so here's the difference. With tangent, we always had vertical asymptotes at our first markings to the left and right, because that's where we would be dividing by 0 on the unit circle. However, we are now using the reciprocal function. So now the 0 would be on top, which is fine. So here's the difference. So cotangent, you're going to start with a vertical asymptote right at 0. That's nice. So new vertical asymptotes for cotangent are right at 0. And again, it's going to be every period. So we have period is pi, so 0 plus pi is pi, or every 4 spaces. Now this all corresponds to the unit circle here. So if you think about the unit circle at, let's see, this point would be 0, 1. Over here would be 1, 0. If we're looking at the tangent here, remember tangent is y divided by x. So tangent y divided by x is 0. But cotangent, if you use the reciprocal of that, that would be 1 divided by 0, which is undefined. So that's why right at 0, you're going to have a vertical asymptote. Over here at pi over 2, we used to have a vertical asymptote, because if you did y divided by x, that would be undefined. That's why we had one for cotangent, or sorry, for tangent. But if we flip that over, it becomes 0 over 1, so there will be a point right at 0. Get what I'm saying? Like, it's the same thing, except it's the reciprocal, so the asymptotes just shift left pi over 2 on everything. So you'll still find your center point, just like you did with tangent. But it's like a reflection of tangent, too. So usually with tangent, we went right one, up one. Now we're going to go right one, down one for cotangent. We're going to go left one, up one. So the graph for a cotangent is the same as the graph of if you had a negative tangent that was shifted left pi over 2. Or right pi over 2, I guess, technically, either way. They're the same. So cotangent and this graph are equal to each other, which is weird. You could all graph this. That's what a cotangent graph equals. So cotangent, vertical asymptote at 0, and it's like a reflection of tangent. So let's try. We got a couple more here. Maybe. Oh, geez. This one's boring. It's just the cotangent reflected, so it's going to look similar to a tangent. So we'll check our period first, because that's what we should always do. Period is pi over b. B in this case is 1. So we have pi over 1. Or I just wrote the same thing twice. Period is pi. Our steps are going to be half of that. So pi divided by 2. So just like the unit circle, we're marking every pi over 2. That's it. So we don't have a left or right shift, which means our vertical asymptote is going to start right at 0. And it's going to happen every 4 spaces if you keep scaling it this way, or every period. So 0 plus pi is pi. 2 pi. Negative pi. Cool. We'll find our center point. And cotangent typically goes down and right, but this is a reflection, so it's going to go up and right. It typically would go left and up, but this is reflected, so it's going to go left and down. There's negative cotangent of x. Looks very similar to if I said write that as a tangent graph, you could say y equals tan x plus pi over 2 or minus pi over 2 or whatever. You just have to shift the asymptotes for that. Cool. One more. Oh, yeah! We got a period change, we got a vertical shift. Whew, I was starting to get bored with those other ones. You know what I mean? So we're going to check the period here. Period is pi over b. Our b here is 1/2. If you divide by 1/2, it's the same as multiplying by 2. So we have pi times 2. Our period is going to be 2 pi. We need to figure out the steps for our labels by dividing that by 2, which means we're labeling every pi. So every 2 spots, we're going to have a pi. Now our vertical asymptotes, we don't have a left or right shift, so our vertical asymptote is still going to be at 0, and it's going to be every period. 0 plus a period would be at 2 pi. Plus another 2 pi at 4 pi. Negative 2 pi, negative 4 pi. Cool. So we'll find our center point. But look at this minus 3. That's going to drop everything down 3. So our center here at pi, we're just going to drop it down 3. We'll find the center of each one of these. That's it. And it's cotangent. So cotangent goes down and right. It goes up and left. All right, that was it. That was pretty fun, right? Probably top 3 funnest things you've ever learned.